Welcome friends to this tutorial on solid design principles. So this is the fourth video on this series. So in previous videos, I already have talked about other principles like single responsibility principle, Liskov substitution principle, and open close principle. So if you have not seen those videos, I'll put the link on the description section. So if you guys are interested, you can go and watch those videos as well. So in this video, I'm going to talk about interface segregation principle. This is the fourth principle on solid design principle. So let's begin. We will begin with the official description of this principle, and it says no client should be forced to depend on methods it does not use. Okay. And what it essentially means is this means that each class should serve a well-defined purpose. Okay. And only expose behavior that is aligned with that purpose. Okay. So what it means is, so if you are writing a class or interface, it should have a well-defined purpose, and the methods that you will be writing into that interface or class, that the objective of those methods should be to fulfill the purpose of the class. We should not put unnecessary methods into a class or interface. Okay. And consumers of that class should not be forced to depend on methods which they do not require. Okay, so you written a class, and suppose you written a class A, and we have another class called class B. So suppose B is using class A, class B is using class A. So in class A, only those methods should be present that class B needs. Okay. It should not have unnecessary methods. And this particular principle is ties nicely with single responsibility principle. If you see the definition of single responsibility principle, so a class would have only one reason to change, right? This is single responsibility principle. And in this interface segregation principle, this statement, a class should serve a well-defined purpose and only expose behavior that is aligned with that purpose. So these two statements are quite similar in a way. So what happens if you are following single responsibility principles, then many times you automatically get this interface segregation principles also implemented without doing any extra effort. Okay, but this does not happen always, but in majority of cases it happens. Okay, so don't worry if you didn't understand this whole description. So I'm going to explain you through an example, and I hope by the end of this video everything will be clear to you. Okay, so let me show you that example. So just to save some time, I already have written some examples to explain you guys. So let's see that. So see, I have written an interface called bank service. Okay, and in bank service interface, we have 6 methods. Obviously, in interfaces, the methods are abstract methods, right? But yeah, in Java 8, afterwards Java 8, you can have static and default methods as well in interfaces. But in this example, we have all the methods are abstract methods. So the methods are it's related to bank, right? So whatever you can do in bank, it contains all means majority of those methods in this interface, like make deposit, make withdrawal, open account, close account, create customer, and disable customer. Okay, so these are the four abstract methods that is there in the bank service. So obviously, in order to use it in your project, you must have a class that implements this method, right? So for that, I have written a class. This is called bank service IMPL. And this class implements bank service interface, this interface. Okay. So because this class is implementing this interface, so I'll have to provide the bodies of all the methods that is coming from the interface, right? So I have overridden all the methods over here, all the 6 methods, as you can see. However, I have not provided the logic to, make deposit. I have not provided the logic of, making a deposit, because that is not the purpose of this video. I'm just explaining you guys through this example just to, clear the concept of interface segregation principle. So I have just provided a empty body, you can say, and I have used this system.out.println just to make sure, if suppose I'm calling this method, how would I know that this method got called or not? So using this message, we can be sure that, yeah, this method was called. Similarly, I have used the system.out.println for all the 6 methods. Okay, so this is done. Then I have a class called automated tailor machine. Automated tailor machine is a full form of ATM. So ATM, what you can do through ATM? Through ATM, either you can deposit, withdraw the amount from any ATM, right? Or in some ATMs, you have machines to deposit also. So through ATM, you can either make a deposit or make a withdrawal. So that's what I'm doing this in automated tailor machine class. I have 2 methods, public void make deposit and public void make withdrawal. And to do this, to make a deposit and withdrawal, I need this bank service class, right? Because the actual implementation is within this IMPL class that is implementing this bank service interface, right? So basically, this class is dependent on bank service, and using bank service, this class is making deposit and withdrawals. Okay, so this is the whole design. Now we will talk whether this particular design is following interface aggregation principle or not. So let's go back to the presentation. So what it's saying, no client should be forced to depend on methods it does not use, and a class should serve a well-defined purpose and only expose behavior that is aligned with that purpose. So let's check whether this class, for example, this class in bank service, we are dealing everything. And because this bank service is the automated teller machine is dependent on bank service, so this class is being exposed with unnecessary methods. You can see, if I want, I can call other methods also from this. So suppose bank service dot, I have access to all these methods: close account, create customer, disable customer, all these, make deposit, that's fine. Suppose I can call this one also close account, right? Because this is exposed to this, because this ATM class is dependent on bank service, and bank service is having all these methods, 6 methods. So this ATM class is exposed with unnecessary methods. this class is only dealing with making deposit and withdrawal. So ideally, these close account, open account, and other these to create customer, disable customer should not have been exposed to this class. But in this particular example, it is being exposed. So this whole design is not following the interface segregation principle. And what is the drawback of not following interface segregation principle is this. So the first problem is it's error prone. As I just showed you, actually suppose you, because this is exposed, because this close account is exposed to this method, developers are humans, right? So humans can make mistakes. So suppose by mistake I call this method instead of make withdrawal. So this is error prone, right? This whole design is, I was able to call this method because this is exposed to this class. So this is error prone. Okay. This whole design is error prone because we are not following interface segregation principle. This is the first problem. Okay. That this is error prone, and the second problem and the most important problem is it degrades the performance of the system. How? Because this class automated tailor machine is dependent on bank service. And suppose in future you developed and like few days later your client came and told that there is a change in the requirement. Now this open account method should take a phone number also. So you come here in bank service and you added long phone number, new input to this method. Earlier it was taking only customer ID and account type. Now it is taking phone number as well. So because you made the changes in the interface, so obviously you need to make the changes in the IMPL class as well. So you came here and you added that extra parameter into the IMPL class as well. So now because you made changes to this method, this class will also recompile. When you will build your project and you will try to deploy your changes, this class will also, this ATM class, automated tailor machine class, will also recompile. Why? Because this class is dependent on bank service and you made the changes on the bank service interface as well as in the class. So because this class is dependent on this class, so this will recompile. However, this particular class was not using this method, right? I'm not using, ATM class is not using this method at all. Despite of not being used, even if this class will recompile because this method is exposed to this class because the design is wrong. Okay. So the compilation, because this compilation takes time. So when you build a project, so one of the part of the building project is compilation. It compiles all the Java classes. So it ultimately you are increasing the overall timing of building your project and the building and deployment, right? So however, in this particular example, this is just one class, right? But in real world project, you may have so many classes interface, and if your design is not right, if you have not followed this interface segregation principle, you will turn up, doing the same mistake for lots of classes interfaces, right? So ultimately, your building time will be increased. So that is the main problem with this. If you are not following interface segregation principle, okay. So now, as we understand the problem, if we are not following interface segregation principle, now let's try to refactor and follow the interface segregation principle. Okay, we will try to do some changes and we'll try to follow the interface segregation principle now. So see the main class is this class is using this interface or class, whatever you say. And this is dealing with only two methods, make deposit, make withdrawal. So why we need all these extra methods over here, right? So you simply comment this out, all these extra. So now in bank service, we only have this make deposit, make withdraw, only two methods. So because you have commented out all those four methods, so you need to comment out over here in IMPL class as well. So I commented out here as well. Okay. I commented out one extra. Okay. So now this IMPL class is implementing only, overriding only make deposit and make withdrawal. That's fine. And all good now. And you may have some other classes like automated teller machine. You may have some other classes, those were using open account, close account, or create customer, disable customer. For them, you create two more interfaces. So I already have created those interfaces. Let me show you. So one of the interfaces, account maintenance service. So these two methods, open account and close account, will be moved to this new interface. Open account and close account, right? And similarly, for customers, we will create a new interface. And these two methods, create customer, disable customer, will be moved to this new interface called customer maintenance service, as you can see here, right? So like this, and you may have classes to implement these interfaces. Okay, you will write class to implement this account maintenance service IMPL, similarly customer maintenance service IMPL, and you will provide bodies to these methods. Okay, so now if you suppose, because this class ATM class is dependent on make service, suppose you make changes over here, as I showed you earlier. So you add new field called phone number. So in that case, there is no, because this ATM class is not dependent on this customer maintenance service. So this will not recompile. Earlier it was recompiling because you had written all the methods in the same interface. That's why that was the problem. So now this class bank service is following the interface segregation principle as per the official description. It's you have a specific objective of each and every classes, and all the methods are trying to fulfill that objective, right? So guys, I think now you guys should be able to understand this the whole concept of interface segregation principle. And if you like my video, please click on the like button and subscribe my channel. And if you didn't like my video, please put your suggestions into the comment box. I'll try to follow them in my coming videos and try to make better videos in future. Okay, thanks for your time. Thank you very much, guys. Bye bye.